I'm sorry.
Come on, guys. Unit 6 introduction. So, like I said before I got started, is that a lot of you probably remember the things we're talking about from last year from your physical science class. Okay. If you do not remember, that's fine. But we're going to have a quick intro. All right. We're going to try to find our bike again and see if we can ride it. All right. Little analogy. It's springtime. Really?
Yeah.
Well, hopefully the analogy works for you then.
I'll go to bike class.
4 through 8. No. I'll take a look in a second. All right. So, introduction. This chapter deals a lot with the term energy. So, what do we remember about energy?
Isn't it an object's ability to exert force?
Can be
It
transferred.
can be destroyed.
Michael doesn't have any. Should eat breakfast.
I did actually.
We figured out how much energy was in a
We
pop
shorthand energy.
We did.
And R.
Okay.
You have a shorthand energy? I get it compared to that.
What
That
else?
doesn't make any sense.
That's not, it can't be created or
Exert.
maybe it can be created. That was something else.
What else?
Equals MC squared.
E equals mc squared. That is energy. Okay, but that's a little bit of theory. That's a little bit of relativity for us. We're not going to do that this year. Okay. Anybody else? What's energy?
It can be
Object's
destroyed, right?
ability.
Can be destroyed.
Can
Or
it be
made.
Energy
Are they being created?
is,
Is that
potential
something
or
else?
kinetic energy.
Okay, so there's types.
Yes. There are types. There's two of them.
So
They're kinetic.
you said kinetic
Potential.
and
Potential.
potential. Now, do you remember the definitions of these?
Kinetic is when the
Energy
object is in
motion.
motion and potential is when the object is in motion.
Okay, shh, guys. The side conversation needs to stop.
Do we write that
Okay. Yes.
Or is that like a guess or something?
Nope. So kinetic is energy of an object in motion.
Energy of an object about to be in motion.
Nope.
Or not in motion.
Nope. What is it?
Stored energy.
Good. Stored energy. Now, how can we store energy?
Put it in a box.
Put it in a box and keep it somewhere, right? No.
Freeze it.
You freeze it. Okay, that's like storing meat. No.
Put it in a sandwich bag.
A battery. Good. A battery, like the one on your cell phone, is stored electrical energy.
Not a very
Right.
big.
Put it in a phone.
So it gets used. It's waiting there to get used, right?
Put it
What's
in
another way
a
to store energy?
Like when you are really high up.
Turn the lights off.
Okay, so if I'm really high up, if I'm standing on, well, we don't have to get the high, we can't get that morbid. All right, look at anything on your table, right? Everything on your table is at a certain height, right? Is it moving right now? No. But if I were to take Michael's iPhone and get it up and move it off to the edge of the table, what would happen to it?
It would almost fall.
It would fall, and then I don't want a new iPhone, right? Okay. So,
Would it break?
but the whatever's on the table, if you push it off the edge, it would fall down, wouldn't it?
Would it?
What would happen to its kinetic energy?
It would increase.
It would increase. Now, one thing you guys already told me was that energy can't be created or destroyed, but it can change forms. Right? Someone said that earlier. So, if something on your table, when it reaches the edge of your table, all of a sudden has energy going downward because of kinetic energy, where did energy come from?
From gravity.
Potential energy, right? And from gravity. Okay? Because the potential energy that anything on your table has is what's called gravitational potential energy. It's energy stored by working against gravity. Okay? So potential energy has multiple types. The one we'll focus on is gravitational. It is the height one. There is an equation. What is it?
Height times 9.8.
What force are we working against? Gravity. Remember the equation for the force of gravity? What's the equation for force of gravity? mg times the height, h. So gravitational potential energy, here's the equation.
That's right on our
PE
fingertips.
equals mgh. Okay.
How about to get A on this?
That's the equation for gravitational potential energy. Now there's other types of potential energy. Like I said, there's electric potential energy. When you bring like charges right next to each other, like what's being stored in your battery of your cell phone, there's a lot of negative charges that are all stored right next to each other. Do negative charges like being by each other? No.
They're magnets.
There is, but we're talking electrical right now. Okay. Those electrons do not like being close to each other. So when you bring them all close together, you're storing a whole lot of what's called electrical potential energy. There is magnetic potential energy when you bring two magnets that are the same end close to each other. They want to push each other apart. Okay. There's also chemical potential energy. Okay. If you eat food, you are storing chemical potential energy in your body. And then when you walk, when you work out, when you sleep even, when you breathe, you are using that energy to get your body to do things. You know, it's just normal functions like breathing, thinking. Well, some of your thinking might not be normal. But breathing, that's a little joke. There we go, thank you. All right. All right.
It's for everyone.
Thank you. No, not for everyone. Only 3 of you laughed.
I laughed a lot too.
Monty wants to make sure she gets her A, right? All right. So, any questions about gravitational potential energy? No? Kinetic energy. Does anybody know that equation? What is it, Whitney?
K-E.
Half something.
K-E equals half of H.
MV squared.
Nope.
MV.
G.
V.
MV squared.
Thank you.
Whoa.
Okay. Because kinetic, guys, depends on what? Velocity. Because it's for objects that are in motion. Right? So there's our kinetic energy equation. So what's the units? Joules. Good. Where'd that come from? Last year, you remembered it. Okay. These are different than the jewels that are on your jewelry. Okay. These are not gems and diamonds. And,
Okay, is there gonna be an actual
different types of
definition
joules.
of energy?
What? Yes, there will be an actual definition of energy. We're working backwards to it, going by what you guys know. The symbol for joules is a J.
Wow.
I thought it was gonna be a P.
Wait, is it work in watts?
No, powers in watts. We'll get to that.
Okay.
So, units are joules.
Wow.
Now, 1 joule
Equals
equals what?
1 meter.
One swag.
I don't know.
Well,
Per meter.
what's the units on mass?
1 kg per.
Kilogram, right?
Yeah.
Per.
What's the units on velocity?
Square. Meters.
Meters per second, and it's squared, right? So that means both the meters and the seconds are squared. Does that make sense?
Oh my god.
Does that make sense, guys?
Yeah.
Okay. Now I'm going to pull these meters squared apart for a second. And you get kilogram meters per second squared times a meter, right? I know there's 2 squared. I pulled the meter apart, Whitney, which pulled the 1 square out.
Yeah, that was
Okay.
not
All right, does that make sense?
I know they look all the same.
Guys, this makes sense? Michael,
What?
this make sense?
I was saying.
No, it's kind of like the equation we did last year.
I took the M apart.
Oh, okay.
Okay?
Let's put it over this way
Yep.
as we did last year.
Now,
Chode fitness.
But why does that mean you put
Michael,
What?
appropriateness.
what?
Okay. M over second squared. What is that?
What?
Acceleration. Good. What's kg? Mass. What's a mass times acceleration? MA. Force. What's the units on force?
Newtons.
Newtons. So 1 joule
We did all this.
1 Newton.
is equal to 1 Newton times a
Mass.
M is not mass in this case. M is a unit. It's a unit.
Meter.
Meter. Thank you. So 1 joule
You can tell his mass or
is 1 Newton meter. Okay, so you think about if you apply 1 Newton of force per 1 meter, we can get some spring scales out tomorrow and actually try it out. If you apply 1 Newton of force for 1 meter, then that's a joule. Okay, does that make sense?
Yeah, why didn't you name your daughter Jewel?
That would be so funny.
It would be kind of cool. All right, gotta get my wife on board for that. And she want to name one of our kids like Skinner or something, or Pavlov, because she's a big psychology person.
You should have picked. You should have picked like a hippie
I got
name.
it. Could be at Skinner.
Like-
She has your age.
Like I don't know.
A hippie name?
Yeah.
I'm not a hippie. All right, energy. So we have some information about energy, but we don't know the definition of it. What's energy? What does energy give you guys? When you guys have energy, what can you do?
Everything. Stay away.
You can do everything, right? What can you do, None?
Jump off buildings.
Say a little louder.
Work!
There you go. So, energy gives us the ability
To do work.
to do work. That's what energy is.
I said that earlier.
New word
Energy is the ability
Of an object to produce a change in itself
To-
or the world around it.
to do work. In short, do work. Okay? Looking it up in the book. You resourceful devil, you. All right. So, I'm a short guy.
No.
Energy is the ability to do work.
That's why we're gonna go this test.
Does that make sense, guys?
Yeah.
Are there any questions?
No.
Are we done?
No, we're not done for the day.
Whoa.
Now-
You said some notes.
There's one more type of energy.
Thermal.
Nope.
Static.
Nope. Potential static energy. It's not real energy.
Theoretical.
There's one other.
Theoretical energy.
Theoretical energy. Nope.
What does it start with?
An M.
A what?
Momentum.
An M.
Magnet.
Nope. Magnetic potential. That's
Wait, what's the second letter?
an E.
Meg.
Louder. One more time. A little louder.
Mechanical.
There we go. So, mechanical energy.
Boy, you didn't say it.
Why did you say it?
Because I thought I was.
Well, that sucks.
Hey, I'll tell you what. 100% of the answers you don't tell me are wrong. So just keep that in mind.
Yeah, I've seen that somewhere.
Yeah, you miss 100% of the shots you don't take.
Yeah.
Yeah, it's a Wayne Gretzky quote. Somebody has a quick Wayne Gretzky. All right. So,
Okay, I'm really mad at the units before the type because now it's all messed up.
thank you.
Wait, so what's up with
So kinetic
you mean after?
and potential energy make up,
Because before.
Whitney,
so when I have all
make up,
types together.
Jose, mechanical energy. So that means that mechanical energy is the sum of kinetic and potential.
So what happens? MG squared plus MG.
So this is the sum of KE and P. That's mechanical energy, right? Energy.
Oh, it's when you add them. Yeah, I remember this.
Star student.
Are there any questions? Any questions? No questions? All right. So now we found the bike.
Oh, where?
Let's see if we can ride it.
There's no pedals.
There's no
Oh,
pedals.
so that's not what we were.
There's two pedals, kinetic and potential.
But Brent, I just don't have the energy to ride it.
We'll eat something then tomorrow morning. Yes.
You know how we were talking about
Oh,
ghetto
one,
names?
like.
At close up, there's this white girl named Dejanay.
Yes,
right.
she's like the white.
I don't-
The only black girl there, and her name is Dejanay.
I don't know how this is relevant. Thank you for sharing.
She
All
was
right.
white. She was like blonde. Was she blonde?
She was like, I don't know what my parents think.
She was like, it's awful mustard. That's what she was like saying. I was
That's
like,
Dijon. All right. Kinetic and potential energy. A 0.45 kilogram football has a velocity of 3 meters per second when it is 4 meters off the ground. Now you guys can use a spherical football or you can use an oblong football. You can pick. All right, I don't care. Whichever football you want. All right. 3 questions. What is the football's kinetic energy? What is the football's potential energy? And what is the football's mechanical energy? All right. Now, I am certain that you guys can calculate these. Okay. So, if you're struggling, make a list, pick an equation, and then plug in.
0.45 times.
Lock's already riding the bike. Lock's like a speed racer. He's halfway down with the sign.
We found the bike, Lock pulled it down, we rolled down the block already, right?
Yeah.
Wait, how do you find?
Lock's just doing laps around us, making fun of us.
Well, Rex, I'll tell you what, not everybody gets a ribbon in this bike race.
Wait, there's the negative in gravity now.
Hey,
Does potential energy have a direction? V equals mgh. Is there any vectors?
No.
No. So since there's no vectors, you think we need the negative sign? No.
That looks more correct.
what did you say, Michael?
Told you, it's getting gifted.
What's this one?
And talented.
You added.
We did. That's why we're reviewing it.
Michael just asked me something.
That's what they. White girls are so.
4 through 8.
I love white
Look it up. Hold on.
Hey, don't look it up. Viewer,
We're already done.
you're already done?
Yeah.
Now you're done already?
Yeah.
Goodness.
Wow, we learned this last
Some people are just getting their folders out and you guys are done already.
Alright, Brian.
We're
Eric's just being his
overachievers.
calculator.
Nod.
Well, good job.
I got it done. Alright.
Oh.
I got 2.03 and
Camouflage back there. Yeah.
That's what number did you use there?
There's so many normal.
Hey, can I borrow this?
Oh, sounds right. Wow, I'm so smart. I should never overthink myself.
So is it gonna be bigger than 9.8?
No. I used to.
Does potential energy have a direction?
Nod, you still 0?
No.
Guys, why are we so loud?
Because we're done.
Goodness.
No, don't start teaching yet.
You don't have to talk to think.
Would it be 9.8 squared?
Who cares?
No. Yeah.
Is the H is the G squared?
Yeah.
Is it?
Don's lecturing.
Well, it's gravity.
Right, but is it squared?
No, gravity is squared.
No, the unit is squared.
I don't care. I'm not having kids. I'll travel the world, eat lots of food. That's what I'm doing.
That would be the best life.
No, I'm so serious. I don't care. I'll travel the world. I'm on first class, international flights, good beds.
Good bed.
By then they'll have like
They
Wi-Fi.
like expansive beds.
How nice was your hotel?
What?
Was your hotel
Our
nice?
roommates suck.
Yeah, it was really nice. But
Wait, what if they just not
I
travel?
don't know. Nice hotel bed.
I did not see my brush or tooth have over there.
Not in the morning.
Let's not do sneeze it.
But they stink.
Yay! Sounds like we're done.
They shower in the morning.
Rex, how's your rib?
It hurts.
Your ribs are good. What's cheap?
You would open our door and you would like
What?
When'd you get purple?
I'm just saying you break her leg.
At night.
She broke her ankle. She stepped off the bus, stepped on top, her ankle twisted like 5 different ways. And then the close-up lady was like, she's not going to the hospital. And this restaurant's like, I'll take her to the hospital and her ankle was broken.
They should have just done some like Mr. Miyagi stuff and have a fireball.
Guys,
She didn't even
thank
throw
you.
up.
Okay, let's transfer down.
the first day she got.
Did you guys have to like carry your house?
So for A, Michael, we're trying to find kinetic energy. K equals 1/2 mv squared. Right? So then we can plug in what we know. So K equals 1/2 times 0.45 times 3 squared. What do we get?
Joules.
Okay, good. For B,
2.64 joules.
for B, mass is the same. What's G? 9.8. What's the height?
4.
So potential energy equals mgh, which equals 0.45, 9.8 times 4. What'd you get, Whitney? 117.6?
17.6.
Yeah, you get 17.6.
We're only going one place.
Oh, he's.
Okay.
Wait,
It's
why do you guys
6'4".
going 6'4", not 6'3"?
Who cares?
Okay.
Go on. Move on.
Okay. Does that make sense? So here we have the kinetic, here we have the potential, right? So for C, when they ask for the mechanical energy, we add those together.
And then we get.
So 2.03 plus 17.64, what do you get?
6.67.
What do you get, Katrina?
19.67. And then it's yeah, I was gonna say.
Are there any questions about that, guys?
That looks like a backwards T.
Can we take a test on this?
Any questions?
Just learn?
No.
Get an A on this test.